I'm Frank Yu. You've seen me in such fine quality, epic chemistry educational videos as Percent Composition in Chemistry, What's the Connection? And does CSI actually bother with finding chemical formulas on accelerants found at the crime scene? Today we're going to be looking at a problem in stoichiometry where we're trying to find the empirical formula given the percentage by mass of the individual atoms that make it up. Now we have to make a difference between the empirical and molecular formula, because the empirical formula, that would be the formula that has the smallest number, the smallest ratio of atoms in the compound. Okay, so in this case here, we have aluminum at 15.77%, sulfur at 28.11%, and oxygen at 56.12%. Where do we go? How do we even start this? Well, the first thing you want to do is make this easy on yourself. You know that it is going to be AL question mark, S question mark, O question mark. We don't know what the numbers are. So this is how we're going to have to find that out. The first thing we want to do is, let's assume we have 100 grams of the material. You'd say, well, why not 50? Why not 25? Why not 1,000? Well, they gave us a percent. And remember, the percent is part over the whole. And we look at 100% being considered the whole. Why can't we make these? We can say 100 grams of the substance, and we can have those changed from percent into grams. So what that's going to give us is 15.77 grams of aluminum. It's going to give us 28.11 grams of sulfur and 56.12 grams of oxygen. Okay, not bad. So that would be our first step that we go through. But okay, we have this mass of these elements. How are we going to get any closer to finding the formula? Well, one of the key things that you want to find, we have to change the mass into numbers. Okay, that would be a very important thing. It's like I have 50 grams of cheese, 150 grams of ham, 250 grams of bread. What's going to be my formula for my sandwich, my ham and cheese sandwich? And that's my analogy for this, because stoichiometry isn't just for chemistry. You use that in other things, like baking ham and cheese sandwiches. Now the question comes down to, great, I've got these masses. It won't do me any good unless I know the number of things. So let's take a look. How do we change this into numbers? Well, you might remember earlier in a chemistry course, you encountered something called the mole. If you don't know what I'm talking about, you need to go back to a previous video where I talk about the mole and the grams per mole and changing moles to grams and grams to moles. You do need to go back, because here I'm going to assume you have that under your belt. So let's go look at this. I need to change this from grams to moles. If I'm going from grams to moles, I need to divide. But what am I dividing it by? Well, how many grams are there in a mole of something? So in this case here for aluminum, it's 26.98 grams per mole. For sulfur, it's 32.07 grams per mole. For oxygen, it's 16 grams per mole. Where did I get those numbers? Did I pull them out of my head? No, not really. I got them from the periodic chart right here. Now this is a little bit, okay, it's not going to let me. Maybe it will? No, it's not. Okay, well, guys, here it is. This is the periodic chart, and this is where I get the information from. Anytime I'm looking for grams to moles, that's where I find it, the periodic chart. Or if you've been doing it for a long time, it comes in and bam, it's there. You do recall it. So this is what we've got. Now, the next thing is we're going to go and divide this so we can find the number that we have here. So in this case here, we have 0.58 moles. We have 0.88 moles. And then we have 3.51 moles. So here we have 0.58 moles of aluminum, 0.88 moles of sulfur, and 3.51 moles of oxygen. Okay, what does that mean for us right now? Well, if we were to go and put our formula together, this is what it's going to look like. It's going to look like Al 0.58, S with 0.88, and O with 3.51. This is not working out very well, is it? The ratio is in there, but we're going to have to work with the numbers a little bit more. There is a proportion that's there. Obviously, there's going to be more oxygen atoms than the aluminum and the sulfur. Now, I don't know if it's more than the aluminum and sulfur put together, that doesn't matter. But oxygen's going to be the biggest one. Okay? All right. All right, so how do we go and resolve this? Well, think about fractions. Think about the fraction like 4/8. And you need to reduce it down to the lowest common denominator. What would that look like? Think back toward middle school, think about toward elementary school. 4/8, 4/8. What numbers do 4 and 8 have in common? Well, they have in common 4, 2, and 1. Well, we want to reduce it. So we should be able to reduce it by, divide them by 4. So 4 divided by 4, 8 divided by 4 gives us 1/2. Why can't we do the same thing here? And you know what? We can. We can go and divide by the smallest number of moles. Now we're going to have to treat everybody exactly like this. So we're going to treat everybody exactly like this. So what is that going to look like? Well, let's see. 0.58 divided by 0.58 is 1. Okay. 0.88 divided by 0.58 is about 1.51. And then we have 3.51 divided by 5.58, and that gives us 6.05. Okay, we're not quite there yet, but we're almost. Because here's the deal. The 6.05, that 0.05 is so tiny, we can go ahead and say, okay, we got 6 oxygens involved. We have 1.51 sulfurs. Well, we can drop that 0.01 and say, all right, here's sulfur with 1.5. And we have 1 for aluminum. So that's the ratio that we have. Now what does our formula look like? Well, it's going to look like Al S 1.506. We're almost there, but we're not done. The question comes down to is, what do we do with this 1.5? And here's the secret. You can't round it down to 1. You can't round it up to 2. Okay? You can't round it down to 1. You can't round it up to 2. So somehow we got to make this a whole number. We can't add 0.5 to it. That's not going to work either. But we can multiply our way out of this. Now, how do we make 1.5 a whole number? Well, we can do two things. We can multiply it by 10, and that would give us 15. We could multiply the 6 by 10 and the 1 by 10. We could do that, okay? But that would be a little bit more work. I'm sitting there and I'm thinking, why can't we go ahead and multiply by 2? Let's make that a whole number. So there would be, we would multiply everybody by 2, so we would have AL2 S3 O12. That's a big molecule, isn't it? Aluminum sulfate. Man, that's huge. Now, is that an empirical formula? Absolutely it is, because we can't break down those numbers any further. So, ladies and gentlemen, that is the answer for our problem here. Okay? As you can tell, that is our empirical formula. Al2S3O12. We're good to go. Hey, let's try another one. Okay? Let's try another one. And I happen to have another example here for people. This one, I promise, is going to be a little bit simpler. Okay? So we have an unknown. It's 40% carbon, 6.72% hydrogen, and 53.28% oxygen. So this is what we've got here. Okay, let's go back. So we need to know, what's our formula? What is the formula that we have here? So we need to change this into grams. Why? Because we have 100 grams of the stuff. Let's make this simple. In 100 grams, we'll have 40 grams. We'll have 40 grams of carbon, 6.72 grams of hydrogen, 53.28 grams of oxygen. Okay? Great, we got numbers. What do we need to do next? What do we need to do next, guys? Change it to numbers. Change it to moles. All right, let's divide it. 12.01 grams per mole from the periodic chart. So now we can change this. We're dividing it by how many grams there are in a mole. So we know exactly how many moles of the stuff we have. So right now, what we've got is we're going to have 3.33 moles of carbon. We're going to have 6.65 moles of hydrogen. And we're going to have 3.33 moles of oxygen. So what does our empirical formula look like at this point? Well, it'll be C, 3.33, H with 6.65, and O with 3.33. That's what the formula is going to look like. And guess what? We need whole numbers, so we're going to have to reduce this just like fractions. Let's divide by the smallest number. So we can divide both of these, all of these, divide by 3.33, like this, because we want to reduce these down to 1. That's the important thing. So it's going to give us C, H, that's going to be like 1.99. That's so close. It's going to be a 2, and then here it's going to be an O. Ladies and gentlemen, I would put forth the argument, this is our empirical formula that we have been searching for. Notice it can't be reduced down any further. It's CH2O. All right, guys, that's it for this one. I'm Frank Yu. Hey, I hope this helped you out. Take care.